Good morning, everyone. We are the Group 6, and our topic is all about the inventory control models. And these are the chapter outline. So, first, let us have a brief introduction about inventory. So, inventory is an expensive and important asset to many companies because it represents as much as 50% of total invested capital and 70% of cost of goods sold. And lower inventory levels can reduce costs by reducing on-hand inventory levels. On the other hand, having low inventory levels may result in stockouts and dissatisfied customers. That's why most companies try to balance high and low inventory levels with cost minimization as a goal. Next, inventory is any stored resource used to satisfy a current or future need. So the common examples of inventory are raw materials, work in process, and finished goods. Next, please. All organizations have some type of inventory control. Inventory planning helps determine what goods and or services need to be produced. Inventory planning also helps determine whether the organization produces the goods or services or whether they are purchased from another organization. And lastly, inventory planning also involves demand forecasting. So in this figure, it illustrates the basic components of inventory planning and control system. So the first one is planning on what inventory to stock and how to acquire it. And the information is then used in forecasting parts or product demand and controlling inventory levels. And lastly, the feedback provides a way of revising the plan and forecast based on experiences and observations. Next, please. So, next is the importance of inventory control. So, we have five importance. So, the first one is a decoupling function. So, one of the major functions of inventory is to decouple manufacturing processes within the organization. If a company didn't store inventory, there could be many delays and inefficiencies. For example, when one manufacturing activity has to be completed before a second activity can be started, it could stop the entire process. However, stored inventory between processes could act as a buffer. Next slide, please. So the next importance is for storing resources. So seasonal products may be stored to satisfy off-season demand, and the materials that can be stored are raw materials, work in process, or finished goods. And lastly, the labor can be stored as a component of partially completed sub-assemblies. The third importance is it is used for irregular supply and demand. So demand and supply may not be constant over time, and inventory can be used to buffer the variability. So for example, if the greatest demand of diet beverage is during the summer, the Diet Delight Company will have to make sure that there is enough to supply this regular demand. This might require the company produce more of the soft drinks in the winter than is actually needed in order to meet the winter demand. The inventory levels of Diet Delight will gradually build up over the winter, but this inventory will be needed in the summer. Next, please. The fourth importance is that it is used for quantity discount. So lower prices may be available for larger orders, and extra costs associated with holding more inventory must be balanced against lower purchase price. And last importance is that it is used for avoiding stockouts and shortages. So, if if a company is repeatedly out of stock, customers are likely to go elsewhere to satisfy their needs. So lost goodwill can be an expensive price to pay for not having the right item at the right time. Next, please. Next are the inventory decisions. So there are only two fundamental decisions in controlling inventory. So the first one is how much to order, and the second one is when to order. The major objective of controlling inventory is to minimize total inventory costs. And the common inventory costs are the cost of the items, cost of ordering, cost of carrying or holding inventory, and lastly, the cost of stock outs. Next, please. So these are the ordering cost factors: the developing and sending purchase orders, processing and inspecting incoming inventory, bill paying, inventory inquiries, utilities, phone bills, and so on for the purchasing department, salaries and wages for the purchasing department employees, and supplies such as forms and paper for the purchasing department. And for the carrying cost factors, we have the cost of capital, taxes, insurance, spoilage, theft, obsolescence, salaries and wages for warehouse employees, utilities and building costs for the warehouse, and lastly, supplies such as forms and paper for the warehouse. So the ordering costs are generally independent of order quantity, and it involves many personal time. So the amount of work is the same no matter the size of the order. While carrying cost generally varies with the amount of inventory or the order size. So as the order size increases, the labor, space, and other costs also increases. And lastly, the actual cost of items purchased varies with the quantity purchased. Next, please. Next is defining EOQ. So what is EOQ? EOQ, or the Economic Order Quantity Model, is one of the oldest and most commonly known inventory control, and it is easy to use but has a number of important assumptions. Next, please. So these are the assumptions under EOQ model. So the demand is known and constant, the lead time is known and constant, the receipt of inventory is instantaneous, the purchase cost per unit is constant throughout the year, the only variable costs are the placing an order or ordering costs, and holding or storing the inventory over time, or the holding or carrying costs, and these are constant throughout the year. And the last one is that orders are placed so that stockouts or shortages are avoided completely. Next, please. So, next is inventory usage over time. So, as what you can see in this figure, it has a sawtooth shape. This is because of the assumptions that I've mentioned earlier. So, the letter Q here stands for amount that is ordered, and for example, it is 500 units, and then the units arrive at one time when an order is received. So the inventory level reaches from 0 to 500 units when an order arrives. And because demand is constant over time, the inventory drops at a uniform rate over time. When the inventory level reaches 0, another order is placed and received, and the inventory level jumps to few units, for example, still 500 units, and this process continues indefinite over time. Next, please. So the inventory costs in the EOQ situation. So we have here the formula and one of the example on how to find the average inventory level, which is equal to Q over 2. So so on April 1, we have the beginning of 10 and ending inventory level of 8. So in order for us to get the average, we need to add the beginning and the ending and then divide it by 2. Same as number 2, add the beginning, which is 8, and ending, which is 6, and then divide it by 2 to get the average of 7. And same process until number 5. So after that, add total the daily averages, and then the total, the sum, will be divided by 5, or the number of days, and then the answer would be 5 units. And these 5 units will be the average inventory level. So next, please. So these are the mathematical equation and what they stands for. So the letter Q stands for number of pieces to order, and the EOQ, or Q to the exponent na may asterisk, stands for the optimal order of pieces to order. B stands for annual demand in units for the inventory item. The C sub O stands for ordering cost of each order, and the C sub H for holding or carrying cost per unit per year. And the formula of annual ordering cost is equal to number of orders placed per year multiplied by ordering cost per year. But in order to get the number of orders placed per year, we need first to divide the annual demand by the inventory level, or by the number of pieces to order. When the EOQ assumptions are met, the total cost is minimized. So when annual ordering cost is equal, the total cost is minimized when annual ordering cost is equal to annual holding cost. And these are the summary of equations. So the annual ordering cost is equal to D over Q multiplied by C sub O, and the annual holding cost is Q over 2 multiplied by C sub H, and the EOQ is equal to the square root of 2 multiplied by D and C sub O over C sub H. Next slide, please. So let us use Sumco as an example. So it is a company that sells pump housing to other companies, and they would like to reduce inventory costs by finding optimal order quantity. So these are the given. The annual demand is equal to 1,000 units. The ordering cost is equal to $10 per order, and the average carrying cost per unit per year is $0.50. So the first, after writing the formula, the mathematical after writing the formula, the mathematical equations will then be substituted to its corresponding values. So 1,000 multiplied by 10 is equal to 10,000 multiplied by 2, 20,000 over 0.50 is equal to 40,000, and then the square root of 40,000 is equal to 200 units. And these 200 units will be the optimal order quantity of Sumco Pump Company. Next, please. So to get the annual cost, we need to add the order cost plus holding cost. So first, we need to substitute and then compute. So for the order cost, 1,000 divided by 2, 200 is equal to 5 times 10 is equal to 50. So the $50, so order cost is worth $50. The next is 200 divided by 2 is equal to 100. 100 multiplied by 0.5, and that would come the result of $50. And then add the order cost and the holding cost, then you will get the $100, which is the total annual cost. Next page, next slide, next. So the total inventory cost can be written to include the cost of purchase items. So given the AOQ assumptions, the annual purchase cost is the annual demand in units is constant at the annual demand in units multiplied by the purchase cost per unit no matter the order policy. And it may be useful to know the average dollar level of inventory. And this is the formula of average dollar level. So C multiplied by Q over 2. Next, please. Next, the inventory carrying cost is often expressed as an annual percentage of the unit cost or price of the inventory, and this requires a new variable which written as letter I that stands for annual inventory holding charge as a percentage of unit price or cost. So the cost of inventory for 1 year is then holding cost is equal to annual inventory multiplied by cost per unit, and the EOQ formula. Next, please. So the E so next is the sensitivity analysis with the EOQ model. So the EOQ model assumes all values are known and fixed over time. Generally, however, the values are estimated or may change. Determining the effects of these changes is called sensitivity analysis. And because of the squared in the formula, changes in the inputs result in relatively small changes in the order quantity. Next slide, please. So still, let us use the Sumco company as an example. So in the Sumco example, earlier the EOQ is worth 200 units. But if the ordering costs were increased for 4 times from $10 to $40, the order quantity would only double. So the 200 units will become 400 units. In general, the EOQ changes by the square root of a change to any of the inputs. Next slide, please. Next is reorder point or determining when to order. So once the order quantity is determined, the next decision is when to order. So the time between placing an order and its receipt is called the lead time or delivery time. When to order is generally expressed as a reorder point. So to get the reorder point, we need to multiply the demand per day by the lead time for a new order in days. So next, please. So for example, so Procom's computer chip. So the demand for its computer chip is 8,000 per year, and the daily demand is 40 units, and the delivery takes 3 working days. So in order to find the reorder point, we need to multiply the daily demand, which is the 40 units, by the delivery time, which is the 3 days, to get the reorder point of 120 units. And an order is placed when the inventory reaches 120 units. And lastly, the order arrives 3 days later just as the inventory is depleted.
EOQ without the instantaneous receipt assumption. When inventory accumulates over time, the instantaneous receipt assumption does not apply already. Daily demand rate must be taken into account. The revised model is often called the production run model. In a production process, instead of having an ordering cost, there will be a setup cost. This is the cost of setting up the production facility to manufacture the desired product. It normally includes the salaries and wages of employees who are responsible for setting up the equipment, engineering and design cost of making the setup, and the cost of paperwork. supplies, utilities, and so on. The carrying cost per unit is composed of the same factors as the traditional EOQ model, although the equation to compute the annual carrying cost changes. The model uses the following variables. Q stands for the number of pieces per order or production run, C sub S for setup cost, C sub H for holding or carrying cost per unit per year, or P as the daily production rate, D as the daily demand rate, and T as the length of production run in days. This is the annual setup cost for production run model. Setup cost, as I said earlier, it replaces ordering cost when a product is produced over time. In production run model, annual setup cost is equal to the demand over the quantity multiplied to the cost of the setup or the setup cost. And annual ordering cost is equal to demand over quantity multiplied to the C sub O or the order cost. In determining the optimal production quantity, by setting setup cost equal to holding costs, we can solve for the optimal order quantity through this equation. As you can see, this is the equation. Annual holding cost is equal to annual setup cost. It is the quantity divided into 2 times 1 minus D over P, and then C sub H equals to demand over quantity or the C sub S. Solving for the quantity, we get the based in the formula below. As you can see in here, it is the square root of 2 times demand times the setup cost over C sub H times 1 minus D over P. In the production run model, these are the summary of equation. In annual holding cost, quantity divided by 2 is multiplied to 1 minus D over P times 2 the C sub H. And this is the annual setup cost, which is equal to demand divided by Q times 2 C sub S. Optimal production quantity is equal to this formula. Let us use the Brown Manufacturing example. Brown Manufacturing produces commercial refrigeration units in batches, and this is are the given. Its annual demand is 10,000 units, setup cost is $100, carrying cost $50 per unit per year, and daily production rate 80 units daily, and its daily demand rate that stands for D is small letter d is 60 units daily. Uh, Using the given, it let's substitute it to the formula, and then this production cycle, as you can see, production cycle is equals to quantity over small letter p is equals to 4,000 over 80 equals to 50 days. Quantity discount models. Quantity discounts are commonly available. The basic EOQ model is adjusted by adding in the purchase or materials cost. It is the total cost is equal to material cost plus ordering cost and holding cost. To get the total cost, you need to use this formula to DC plus D over Q times C sub O plus Q over 2 times C sub H, where the capital letter D stands for the annual demand in units, C sub S ordering cost of each order, and C for cost per unit, and C sub H is the holding or carrying cost per unit per year. Quantity discount models. A typical quantity discount schedule. This is an example of a schedule in this. Buying at the lowest unit cost is not always the best choice in quantity discount models. Quantity discount models. Total cost curve for the quantity discount model. As you can see the figure below, this is the curve for discount 1, discount 2, and discount 3. Let's use the brass department store example. Brass department store stocks Toy race cars. The supplier has given them the quantity discount schedule shown in Table 6.3. Annual demand is 5,000 cars, ordering cost is $49, and holding cost is 20% of the cost of the car. The first step is to compute the EOQ value for each discount. As you can see, you need to just the to use the formula below and substitute the given. The second step is to adjust quantities below the allowable discount range. The EOQ for discount 1 is allowable, and the EOQs for discounts 2 and 3 are outside the allowable range and have to be adjusted to the smallest quantity possible to purchase and receive the discount. The third step is to compute the total cost for each quantity. The fourth As you can see, this is the second step. And the fourth step is to choose the alternative with the lowest total cost. The, Here is an Excel example from the Bass department store example. Use of safety stock. If demand or the lead time are uncertain, the exact ROP will not be known with certainty. To prevent stockouts, it is necessary to carry extra inventory called safety stock. Safety stock can prevent stockouts when demand is unusually high. Safety stock can be implemented by adjusting the ROP. The basic ROP equation is ROP is equals to D times L. Stands for the daily demand or average daily demand, and L stands for order lead time or the number of working days it takes to deliver an order or average lead time. A safety stock variable is added to the equation to accommodate uncertain demand during lead time, where ROP is equals to D times L plus SS, where SS stands for the safety stock. And here is a figure for the safety stock. Use of safety stocks, and this is where the stock out is avoided when you use the safety stock model. Single period inventory models. Oops.
Single period inventory models. Single period inventory model is designed for some products that have no future value beyond the current period. These situations are called news vendor problems or single period inventory models. Analysis uses marginal profit (MP) and marginal loss (ML) and is called marginal analysis. With a manageable number of states of nature and alternatives, discrete distributions can be used. When there are a large number of alternatives or states of nature, the normal distribution may be used. So in single period inventory model, there are two approaches that we're gonna learn. Marginal analysis with discrete distributions and marginal analysis with a normal distribution. First is the marginal analysis with discrete distributions. We stock an additional unit only if the expected marginal profit for that unit exceeds the expected marginal loss. So P is equal to probability that demand will be greater than or equal to a given supply or the probability of selling at least one additional unit. And 1 minus P is the probability that demand will be less than supply or the probability that one additional unit will not sell. Next check. The expected marginal profit is probability times marginal profit. The expected marginal loss is 1 minus probability times marginal loss. The optimal decision rule is to stock the additional unit if the probability times marginal profit is greater than or equal to 1 minus the probability times marginal loss. With some basic mathematical manipulation, there are many ways in which we can determine the level of probability using these equations, and the main equation is the probability is greater than or equal to the marginal loss divided by the marginal loss plus the marginal profit. Steps of marginal analysis with discrete distributions. Step 1. Determine the value of marginal loss divided by the sum of marginal loss plus marginal profit for the problem. Step 2. Construct a probability table and add a cumulative probability column. Step 3. Keep ordering inventory as long as the probability of selling at least one additional unit is greater than the marginal loss divided by the marginal loss plus the marginal profit. Let's apply these steps in Café de Donut example. The cafe buys donuts each day for $4 per carton of 2 dozen donuts. Any cartons not sold are thrown away at the end of the day. If a carton is sold, the total revenue is $6. The marginal profit per carton is $2. So marginal profit is equal to $6 minus $4 equals $2. The marginal loss is $4 per carton since marginal loss is equal to the cost. Then, let's make probability distribution of daily demand. Since it is a discrete distribution, it means given na yung probability niya. So, dito may 5% or 0.05 probability that 4 cartons of donuts will be sold, 15% or 0.15 probability that 5 and 6 cartons of donuts will be sold. Then 20% or 0.20 probability that cartons of donuts will be sold, and so on and so forth. As you can see in that table. Then step 1, determine the value of marginal loss divided by the marginal loss plus the marginal profit for the decision rule. Using the main equation, the probability is greater than or equal to the marginal loss divided by the marginal loss plus the marginal profit. By substituting the given numbers, $4 divided by $4 plus $2 equals 4 over 6 or 0.6666. Then, there is example kay girand off nila maong na 0.67. So, the probability of optimal stock is 0.6666 or 0.67. Step 2. Add a new column to the table to reflect the probability that donut sales will be at each level or greater. Then, same lang kung sa table guy na gidagdagan lag column. Then, mag-start ka sa 100%. Karing 1, i, ano siya, from the given na 100 i-minus sa 0.05 tong probability sa 4 is equal to 0.95. Then, i-check na to if pasok siya sa optimal decision rule. So, since pasok pa siya kay 0.95 is greater than 66. I-continue lang nato ang procedure. 0.95 minus 0.15 tong probability sa 5 cartons of donuts. Ang answer is 0.80. Butang nato ang answer sa ilalom. Then 0.80 minus 0.15 tong probability sa 6 cartons. Ang answer sa baba na po sa 0.80. Ingato lang then dire kay ang sa diri sa example kay taman lang ta sa 0.80 since dira lang man taman ang pasok sa optimal decision rule, so stop na ta dira and proceed sa step 3. Step 3. Keep ordering additional cartons as long as the probability of selling at least one additional carton is greater than P, which is the interdifference probability. So based sa gibat nato sa table sa taas, up to 6 cartons lang pinaka-safe number of stocks with greater probability demand nga masold. nga ilang i-purchase para walay matambak sa inventory room nga malabay lang nila at the end of the day. Next is the marginal analysis with the normal distribution. We first need to find four values: the average or mean sales for the product, the standard deviation of sales, the marginal profit for the product, MP, the marginal loss for the product, ML, and then we let X asterisk is equal to is the optimal stacking level. Steps of marginal analysis with the normal distribution. Next steps. First is determine the value of marginal loss divided by marginal loss minus marginal profit for the problem. Then locate P on the normal distribution table and find the associated Z value. Find X asterisk using the relationship Z is equal to X asterisk minus average or mean sales for the product over standard deviation. To solve for the resulting stacking policy, optimal stacking level is equal to the average or mean sales for the product plus Z value times the standard deviation of sales. Let's try the steps in newspaper example. Demand for the Chicago Tribune at Joe's newsstand averages 60 papers a day with a standard deviation of 10. The marginal loss is 20 cents and the marginal profit is 30 cents. Since given na ang 4 values, let's proceed na sa step 1. Joe should stock the Tribune as long as the probability of selling the last unit is at least marginal loss divided by the sum of marginal loss and marginal profit. I-substitute na to siya. Ang result is 0.40 para sa table 0. So let P is equal to 0.40. Step 2. Using the normal distribution or normal table, we find the appropriate Z value. Z is equal to 0.25 standard deviations from the mean. Then ang formula to determine the area under the normal curve is 100% or 1 minus probability of optimal stock, which is 0.40 equals 0.60. So the illustration, 0.60 ang area under the curve, both left and right side. There is a right side. Kanang sa right side na ay color blue, mauna ang ang Z value. The next step is to determine the optimal stock X asterisk based on the average sales and standard deviation. In this problem, the average sales is 60 and the standard deviation is 10. So, substitute nato sila using the formula and ang result is 62 newspapers. Thus, Joe should order 62 newspapers since the probability of selling 63 newspapers is slightly less than 0.40. So, dapat 62 newspapers lang siya tama. Next is ABC analysis. The purpose of ABC analysis is to divide the inventory into 3 groups based on the overall inventory value of the items. Group A items account for the major portion of inventory cost, typically about 70% of the dollar value but only 10% of the quantity of items. Forecasting and inventory management must be done carefully. Group B items are more moderately priced. May represent 20% of the cost and 20% of the quantity. Group C items are very low cost but high volume. It is not cost effective to spend a lot of time managing these items. Summary of ABC analysis. So as you can see in this table, ABC analysis is all about prioritizing items based kung unsa sila ka mahal o ikapila sila ginagamit sa pagbuhat sa product. So take note that First category is not only costly but also requires better material handling. Next is check. Next na check ikaw.
Okay. Next is the dependent demand, or the case for material requirements planning. All the inventory models discussed so far have assumed demand for one item is independent of the demand for any other item. However, in many situations, items demand is dependent on demand for one or more other items. In these situations, MRP can be employed effectively. Some of the benefits of MRP are increased customer service levels, reduced inventory costs, better inventory planning and scheduling, higher total sales, faster response to market changes and shifts, reduced inventory levels without reduced customer services. Most MRP systems are computerized, but the basic analysis is straightforward. Material structure 3. The first step is to develop a bill of materials, or BOM. The BOM identifies components, descriptions, and the number required for production of one unit of the final product. From the BOM, we can develop a material structure tree. We use the following data. Demand for product A is 50 units. Each A requires 2 units of B and 3 units of C, and each B requires 2 units of D and 3 units of E. Each C requires 1 unit of E and 2 units of F. Here is the material structure tree for item A. A on the top, and then as you can see here, A requires 2 units of B, 3 units of C, and B requires 2 units of D, 3 units of E, and C requires 1 unit of E and 2 units of F. And that's how the material structure tree. It is clear from the three that the demand for B, C, D, E, and F is completely dependent on the demand for A. The material structure tree has 3 levels: 0, 1, and 2. Items above a level are called parents. Items below any level are called components. The number in parentheses beside each item shows how many are required to make the item above it. We can use the material structure tree and the demand for item A to compute demands for the other items. Here is part B. 2 times number A of A's, 2 times 50 equals to 100. Part C, 3 times number of A's, 3 times 50 equals 150. Part D, 2 times number of B's equals 2 times 100 equals to 200. Part E, 3 times number of B's plus 1 times number of C's equals 3 times 100 plus 1 times 150 equals 2 for 50. And part F, 2 times number of C's equals to 2 times 150 equals to 300. Gross and net material requirements plan. One of the material structure tree is done, we construct a gross material requirements plan. This is a time schedule that shows when an item must be ordered when there is no inventory on hand, or when the production of an item must be started in order to satisfy the demand for the finished product at a particular date. We need lead times for each of the items. For instance, an item A needs 1 week, item B 2 weeks, item C requires a week, item D a week, item E 2 weeks, and item F for 3 weeks. Here it is. A net material requirements plan can be constructed from the gross materials requirements plan on-hand inventory information. Here's the table, which is the item and its on-hand inventory. Using this data, we can construct a plan that includes gross requirements, on-hand inventory, net requirements, planned ordered receipts, planned order releases. The net requirements plan is constructed like the gross requirement plan. It's like that. two or more end products. Most manufacturing companies have more than one end item. In this example, the second product is AA and it has the following material structure 3. AA requires 3 units of D or 2 units of F. If we require 10 units of AA, the gross requirements for parts D and F can be computed. Part D and F, 3 times number of AAs equals 3 times 10. Just multiply it by 10 and it will be equals to 30. And in part F, 2 times number of AAs equals to 2 times 10 equals to 20. The lead time for AA is 1 week. The gross requirement for AA is 10 units in week 6 and there are no units on hand. This new product can be added to the MRP process. The addition of AA will only change the MRP schedules for the parts contained in AA. MRP can also schedule spare parts and components. These have to be included as gross requirements. Just-in-time inventory control.
Just-in-time inventory control. To achieve greater efficiency in the production process, organizations have tried to have less in-process inventory on hand. This is known as GIT, just-in-time inventory. The inventory arrives just in time to be used during the manufacturing process. One technique of implementing GIT is a manual procedure called Kanban. Next na siya. Enterprise Resource Planning. MRP has evolved to include not only the materials required in production, but also the labor hours, material costs, and other resources related to production. In this approach, the MRP 2 is often used and the word resource replaces the word requirements. As this concept evolved and sophisticated software was developed, these systems became known as Enterprise Resource Planning or ERP systems. The objective of an ERP system is to reduce costs by integrating all of the operations of a firm. Starts with the supplier of materials needed and flows through the organization to include invoicing the customer to the final product. Data are entered only once into a database where it can be quickly and easily accessed by anyone in the organization. Benefits include reduced transaction costs, increased speed and accuracy of information. Almost all areas of the firm benefit. There are there are drawbacks. The software is expensive to buy and costly to customize. Small systems can cost hundreds of thousands of dollars. Large systems can cost hundreds of millions. The implementation of an ERP system may require a company to change its normal operations. Employees are often resistant to change. Training employees on the use of the new software can be expensive. That's